Hello everyone, welcome to the tutorial on machine learning algorithms. In this tutorial, we discuss in detail about the machine learning algorithms one by one. First one is Naïve Bayes algorithm. Naïve Bayes algorithm. It is a very popular and fast classification algorithm. So Naïve Bayes algorithm is recommended to work with large volumes of data, even with millions of data records. To understand this Naïve Bayes algorithm, we need to have a good understanding of Bayes theorem first. And again, to understand the Bayes theorem, we should have strong understanding of conditional probability. In this video, we discuss quickly about some important terms in probability and discuss in detail about conditional probability and Bayes theorem. What is probability? Probability is how likely something is to happen. In most of the events, we cannot predict the outcome 100% in certain. So we are using the probability. For example, when a coin is tossed, there are two possible outcomes. Either it will be head or it will be tail. We call it as H or T. Now the probability of getting head is 1 by 2. That is P of H is 1 by 2. Because when you toss a coin, you get only one head. So that is this one. And this 2 is there are two outcomes in this event, head and tail. So that is why P of H is 1 by 2. Similarly, probability of getting tail, that is P of T, equal to 1 by 2, because we can get only one tail when you toss a coin. And again, there is a possibility of two outcomes, that is why it is 1 by 2. So in general, probability of any event happening equal to number of ways it can happen. That is, when you toss a coin, to get a head, we are having only one way. Similarly, to get a tail, we are having only one way, divided by total number of outcomes. That is, we can get either head or tail. So there are two possible outcomes. Let us start discussing the other important terms in probability. What is an experiment and sample space in probability? Experiment. Experiment is a repeatable procedure with a set of possible results. Let us understand with some example. When you throw a dice, we can throw the dice again and again, which means it is a repeatable procedure. We can call this as an experiment. What is the possible results we get when you throw a dice? The set of possible outcomes are 1, 2, 3, 4, 5, 6. These set of possible outcomes are called sample space. So sample space is all possible outcomes of an experiment. In this example of throwing a dice, this 1, 2, 3, 4, 5, 6 is called the sample space. Outcome is any possible result of an experiment. This 1 is an outcome of the experiment of throwing dice, 4 is also an outcome. Similarly, 6 is also an outcome. What is events? Events are one or more outcomes of an experiment. Here, 2 is an outcome. It is a single outcome. So events are one or more outcomes of an experiment, which means events are the subset of this sample space. Events are one outcome event or more than one outcome event. So some examples of one outcome event are getting a tail when tossing a coin. Again, getting a head when tossing a coin is also an one outcome event. Again, rolling 5 in a dice, rolling 3 in a dice, and so on. Event with more than one outcome. Choosing a king from a set of cards. That is any of 4 kings. Here there are 4 possible outcomes. And rolling a even number in a dice. 2, 4 or 6. Here there are 3 possible outcomes. Similarly, rolling a odd number in a dice. 1, 3 and 5. So there are also 3 possible outcomes. And all are valid outcomes. Now what is an independent event? Just now we see what is an event. Now I will explain what is independent event and what is dependent event. Events can be independent, which means each event is not affected by any other events. For example, tossing a coin is an isolated thing. The result of the past toss will not affect the current toss, which means when you toss a coin, you can get a head. And again, if you toss a coin, you may even get a head again. This result will not get affected by the previous result. So each toss is an independent event. Now, dependent event. Here, the current event can be affected by the previous events. Let us take an example of picking a marbles from a bag. In step 1, there are 2 blue marbles and 3 red marbles are placed in a bag. In step 2, we are taking 1 marble out of bag. We call it as first event. Now, probability of getting a blue marble as first marble is 2 by 5, because in the bag we are having 2 blue marbles. So the possible chances are 2, and the total possible outcome is 5, because there are 5 marbles in the bag. Now step 3, taking second marble out of bag. That is, we are taking another marble from the bag. We call it the second event. Now the probability of getting a second blue marble, second also blue marble we are getting, will be based on what color marble we got in the first event in real. In the first event, we may get red or blue. So depending upon the first event, the probability is 1 by 4. If you get first marble blue, I will explain you this with this diagram. Consider this as a bag which consists of 3 red marbles and 2 blue marbles. The probability of getting a blue marble as the first event will be 2 by 5, because we are having 2 possible chances of getting blue marbles and total of 5 outcomes. So that is why it is 2 bar 5. Similarly, the possibility of getting red marble in the first event is 3 by 5, because we are having 3 marbles in the bag and there are 4, and there are totally 5 outcomes we are having. And in the second event, the possibility of getting blue marble is 1 by 4 if we get a blue marble in the first event. On the other hand, the possibility of getting blue marble in the second event is 2 by 4 if we got a red marble in the first event, because in both these cases the sample space are changing. Here the sample space is 1 blue marble and 3 red marbles, but here the sample space is 2 blue marbles and 2 red marbles. Coming to the slide, if the first marble is blue, then the probability is 1 by 4, and if first marble is red, then the probability is 2 by 4. Here the second event depends on the outcome of the first event, and it is called dependent event. So in the first event, I choose blue marble. Now the sample space become 1 blue marble and 3 red marbles. From this I am choosing blue marble. Otherwise, if you choose red marble at the first event, the sample space becomes 2 blue and 2 red. So from this 1 blue and 3 red, the chance of picking a blue marble is 1 by 4, because 1 is the blue marble, which is the valid chance, and there are 4 outcomes, that is 1 by 4. So now, what are the chances of getting 2 blue marbles at the end of both of the events? So the answer will be 2 divided by 5 into 1 divided by 4. Please note that we have multiplied the chances of both the events. That is 2 by 5 into 1 by 4, which is equal to 2 by 20, and finally we are getting 1 by 10. So the chances of getting 2 blue marble is 1 by 10. Hope you understand this tree diagram, where the sample space is varying depends upon what we are picking. Here comes the conditional probability. Now, the probability of event A, that is getting blue marble first, we can say P of A equal to 2 by 5. But probability of event B, that is getting blue marble in the second event, we call it as P of B. P of B is a dependent event here. So its probability will be depends upon the first event. If first one is blue, then the probability, if first one is blue, then P of B is 1 by 4, and if first one is red, then P of B is 2 by 4. So, to find the probability of event B, we need to decide which probability we want. That is, P of B with the first one blue or P of B with the first one red. So, now we have two choices. So, we need to write this probability as P of B given A. Here we call this symbol as given. So P of B given A, which means event A already happened. What is the chance of event B? So that is why we call it as P of B given A. So this P of P given A is called conditional probability. So P of B given A equal to 1 by 4. So I am choosing blue marble first. That's why the P of B given A will be 1 by 4. So probability of getting 2 blue marble equal to P of A into P of B given A. So and we are getting 1 by 10. That we already calculated. Now we understand that probability of both A and B equal to probability of A into probability of B given A. Here please make note that, for example, if my sample space is having 1, 2, 3, 4, 5 and 6. In event A I am picking all the odd numbers, and in event B I am picking all the odd numbers which is greater than 4. What happened if the event B happens first? Event B is what? Event B is picking the odd numbers which is greater than 5. Sorry, greater than 4. So B equal to 5. I am picking 5. What is event A? Event A is all the odd numbers. So here the odd number is only 5. So I am taking 5. When you consider as a events, either A follows B or B follows A, we end up with A intersection B. That is, the final set is same. Here also 5, here also 5. If A happens follows B, we get 5. Similarly, if B follows A also, we get only 5 as a result. That is, the result is A intersection B. But when we get into probability, that is P of B given A or P of A given B, it is different because the sample space for both are different. Here, the sample space for B given A already happened is 135. The same way, the sample space for A given B already happened is only 5. So, sample space for P of B given A is A, and sample space for P of A given B is B. This understanding is more important for the Bayes theorem. Bayes theorem. From the conditional probability, we know that P of A intersection B equal to P of A multiplied by P of B given A. From this we can get P of B given A equal to P of A intersection B by P of A. Similarly, P of A given B equal to P of A intersection B by P of B. This diagram is showing the events A and B, and the shaded portion in this diagram is A intersection B. Here event A happens, the probability of B happens given A happens is equal to A intersection B by the probability of A. So probability of B given A equal to probability of A intersection B, this common portion, divided by P of A, this shaded portion, probability of A. Similarly, here B happens, so the probability of event A also happens given that B happens. So that is P of A given B equal to, again, P of A intersection B, the common portion, divided by here probability of B. So from this we can derive P of A intersection B equal to P of B given A into P of A. Similarly, P of A intersection B equal to P of A given B into P of B. In both of these statements, P of A intersection B is common. Here you can clearly understand P of A intersection B is common. So equating both of these statements, we are getting P of B given A into P of A equal to P of A given B into P of B. Then we get P of B given A equal to P of A given B into P of B by P of A. This is Bayes theorem. And this theorem is very important for Naive Bayes algorithm. That is all about this video. In next video, we discuss more about Naive Bayes algorithm. Please subscribe my channel and click notification icon. If you like the content, please hit the like button and share with your friends. Thank you.